Let's continue with more questions. Now, from the chapter acid basis salts. Now, I have taken the first question here in the part A. We have to write down the chemical formula of hydrated copper sulfate and anhydrous copper sulfate. And we also have to write an activity to illustrate how they are interconvertible. Well, hydrated copper sulfate is what? That is CuSO4.5H2O. As you can see that it is a water of crystallization and has 5 water molecules. Now to illustrate how they are interconvertible, that means this is say CuSO4 dot 5H2O. This is 5 here. And when it is heated, it loses water of crystallization. That means it will lose water of crystallization. And as you know that this copper sulfate, the hydrated one is blue in color. And when it loses its water of crystallization, then it turns into white powder. And they are interconvertible. That means hydrated to anhydrous, right? And the reverse is also possible. That is, if this copper sulfate is exposed to moisture or water, it will absorb exactly 5 water molecules, 1 formula unit of CuSO4, and it will turn into crystal, that is CuSO4.5H2O. So in the reverse case, as I can see here, that's white powder now will turn into blue colored copper sulfate crystal. So that is a reverse reaction that takes place. And in fact, this reaction, this one is also used in detecting the presence of moisture. Like if there is a container and if you want to figure out whether there is moisture present inside or not, so what you can do, you can place anhydrous copper sulfate. And if it absorbs moisture and it turns into blue, it indicates that moisture is present or maybe was present. Now, there is one more question. We have to write down the chemical name and formula of plaster of Paris, right? And gypsum. We have to write both of it. Now, plaster of Paris, also known as POP, is calcium sulfate hemihydrate. I'll show you where it is. This is plaster of Paris's calcium sulfate hemihydrate, that is CaSO4.5H2O, and gypsum is CaSO4.2H2O. So first I'll write for plaster of Paris, that is CaSO4 dot, it has half water molecules attached, that is for POP. And for gypsum, it has 2 water molecules, that is CaSO4.2H2O. This is gypsum. In fact, you should know that if water is added on POP, it absorbs 1.5 water molecules and turns into this gypsum. And in the next question, it says state the chemical properties on which the following uses of baking soda are based. The first as an antacid. Now we should know that antacid is baking soda is a mild base. Baking soda is a mild base and it is non-corrosive. Here I have written, this is baking soda is a mild base and it is non-corrosive in nature, and that's why it is used as an antacid. So one more time, and baking soda, right? Baking soda is a mild base, it's a mild non-corrosive base, and therefore it helps in neutralizing the excess acid produced in the stomach, and that's why we use it as an antacid. Well, in the next part, I see the next part here is to find out its use as a soda acid fire extinguisher. Well, we know that on heating or mixing with acid, it releases large amount of carbon dioxide. So carbon dioxide, as you know, is a non-supporter of combustion, and in fact, it extinguishes fire. And that's the reason why we use it for in a fire extinguisher. And the next one here is to find out the why it is its application in bakery industry, that is for making bread and cakes soft and spongy. So what I have already explained to you that this is used in bakery industry because of these reactions. So when it is mixed with a dough, this baking soda, when it is mixed with a dough, say NaHCO3, that's mixed with the dough, and when it is heated, it results in formation of sodium carbonate, Na2CO3 plus water and plus carbon dioxide. Now, this carbon dioxide gas escapes out of the dough by making tiny holes on it, and that makes it fluffy. So if you can figure out from here, I try explaining you like this be the dough, and it makes tiny holes as the makes tiny holes over here, and the dough as it expands, it rises, and that's by making holes, and that's the reason we use it in bakery industry. So the next question says, a student detected the pH of 4 unknown solutions. These are A, B, C, D as following. That is for A, it is 11. For B, it is 5. And for C, it is 7. And for D, it is 2. We have to predict the nature of the solution. Well, you should know about the pH here that for a acid, right, this is not correct. Let me erase this. This I've taken a wrong one. So you should know that the pH of A is 7. That means, first thing you should know that for a neutral substance, the pH is 7. And as the strength of an acid increases, the pH decreases. And the most acidic is 0. As the pH increases, its basic character increases. And the most basic has a pH of 14. Now we can see here that the first sample, that is sample A, is somewhere here, right? Somewhere here on the pH scale. This is substance A. So it's going to be basic in nature, right? We just have to say basic. We can say it is, alkaline also. Now the next is 5. Now 5 is somewhere here. So we can say that, let me use some other color. This is 5 here. So we can say it is acidic. Well, but it should be weak acid, right? Weakly acidic. And the last one is 2 here. The 2 is over close to 0, right? So it will be highly acidic. So this is highly acidic, weakly acidic. 7, as you know, it's neutral. So it's neutral. This is alkaline. That is, now we can write A, B, C. So A I have written already here. That is, it is alkaline. B is what? B is 5. So I'll say that this is B here. That is weakly acidic. Then C is over here. So C is neutral, and D, which is here, then that is whose pH is 2. So it has to be strongly acidic. Now, as we proceed to the next question, we have another question. It says, give the constituent of baking powder. Well, baking powder is constituent, right? We are talking about baking powder, not baking soda. So this baking soda, when mixed with a small amount of tartaric acid, it results to give baking powder. So that's all you have to write down. This baking powder has 2 things. One is baking soda, and the other is an edible acid. Mostly it is tartaric acid. This is tartaric acid. Now, in the next part, the question is why the cake or bread swells on adding baking soda. So for that, you have to mention about this reaction. Let me once again write down the reaction. Everything got wiped out. Yes, here I'll write it. So baking soda or baking powder, its chemical constituent formula will remain same. That is NaHCO3. When it is heated, it results in formation of sodium carbonate plus water, and the carbon dioxide gas is released. So the gas so released in this process, right, that is carbon dioxide, make tiny holes on the cake and make it fluffy. You have to write down the chemical equation, and I've already written the chemical equation. Now, next I have taken 5 questions, one question with 5 parts. The question here is, if equal amount of magnesium resin are taken in a test tube A and B having H2SO4, that is and sulfuric acid is added on the test tube A, and carbonic acid, that is H2CO3, is added on test tube B in equal amounts, we have to identify in which case the reaction will be vigorous, right? So we need to figure out in which case the reaction is vigorous. So let's do with the first thing here. That means I am dealing with this question at a time. One question is this. Now we know that this hydrochloric acid, sulfuric acid, is a strong acid. But we know here that sulfuric acid is a strong acid, and carbonic acid is a weak acid. So clearly, sulfuric acid will release. The reaction will be more vigorous in this case. That is in test tube A. I think H2SO4 is added in test tube A. Yeah. So we'll say that in test tube A, the reaction will be vigorous. The reason for supporting the answer is this, because sulfuric acid is a strong acid and carbonic acid is a weak acid. So in case of sulfuric acid, it gets completely ionized, and in case of carbonic acid, is partially ionized. Now, to the next question, it says, name the gas liberated in both cases. And how will you prove that? What we know that whenever an acid reacts with water, right? Acid reacts with metal, right? So metal here is magnesium. It gives salt and hydrogen gas. Hydrogen gas is liberated. Well, we have taken magnesium in this case. So magnesium, and let's say first one is H2SO4. So it will give you magnesium sulfate, MgSO4, and hydrogen gas will be released. So hydrogen gas will be released in this case, that is the first one. But hydrogen gas will also be released in the other case also, because this is a general reaction where any metal, except for the noble metals, when reacts with acid, that is here I am taking H2CO3, then it results in the formation of magnesium carbonate. This time the salt, but hydrogen gas is there, right? So the chemical reaction I have written for these two also. I've written the chemical reaction. Where is that question? Yeah, I've written the chemical reaction here. For the D part, we have done it. Now the next is, out of which two acids taken, which one will have a lower pH? So lower the pH and higher is the strength of an acid. You should know that the pH varies from 0 to 14, well, 7 being neutral. So the lower the pH, more is the strength. So we'll say that out of the two, which will have a lower pH, the one which has a more acidic, right? So strength of an acid H2SO4 is more, and that's why we'll say that it will have lower pH. And the strength of H2SO4 is less acidic, and that's why it will have a higher pH, right? By higher, I mean to say towards this, not more than 7, but less than 7, but more than 0. Now, lower H plus concentration. So H plus concentration, let's begin with this same thing again. I said H2SO4 is a strong acid, or the strength is more, so it will have low pH. It will have lower, right? Lower pH, but strength is more. Once again, on lowering the pH, On lowering the pH, the strength of an acid increases. And that's why. Now, lower H plus ions concentration, right? So we are talking about H plus ions concentration. So H plus ions is responsible. This is an important question. Let me elaborate it. So I'm hiding this portion. Right. Coming to the question once again. First, I'm drawing a pH scale here. So this is 7 for the neutral, 0 for the most acidic, and 14 for the most basic. Out of H2SO4, that is H2SO4 and HNO3. Is it H2NO3? H2CO3, sorry. H2CO3, that is carbonic acid. Yeah. Okay. So this is sulfuric acid and it will have lower pH, right? Because it is more acidic, and H2CO3 will have higher pH. We don't have to do its exact value, but this will be closer to 7. This is closer to 0. Now, the next part is H plus ions. We should know that H plus ions concentration, that is, we write H plus AQ, that is hydronium ions, or sometimes H3O plus simply. This is hydronium ion concentration will be more in case of a stronger acid. That means stronger the acid, higher the H plus ion. So we know that H2SO4, we have concluded that it is more acidic. Therefore, it will have greater number of H plus ions, or concentration, not numbers. Concentration of H plus ions will be more in sulfuric acid and less in nitric acid.